Now let's move on to the periodic trends. Okay, but however, before we move on, let's go for some practice. So let's draw the electronic structures of the elements seen in the table. The tables are found in your worksheet. So let's draw the electronic structure for all of these elements over here. So we have lithium, Li37. Okay, what's the electronic configuration? You look at the number here, it is 2.1. So let's draw lithium. So how many electron shells? It has 2 electron shells. Okay, first electron shell has 2 electrons. Second electron shell, it has 1. Okay, now let's look at sodium. Sodium, Na1123. So for sodium, it has electronic configuration 2.8.1. So sodium electronic configuration, it has 3 electron shells. Okay, first shell 2 electrons. Second shell 8 electrons. And the last shell 1 electron. Now let's look at group 7. Group 7 we have fluorine F919. Okay, so I know the electron configuration is 2.7. So F, 2 electron shells. Let's use a dot to denote this. So 2 in the inner shell, 7 in the outer shell. And the last one we have chlorine 1735.5. Electronic configuration, look at the number inside here. So this is 2.8.7. Chlorine 1, 2, 3 electron shells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, you can see 2, 8, 7, 17 electrons over here. So these are the electronic structure of your lithium, sodium, fluorine, and chlorine. What do you notice about them? If you compare in rows, okay, lithium and fluorine are from the same group. So same group over here, okay, same group. Yes, same period. When they are same period, what do you realize? How many electron shells do they have? 2. So same period equals to same electron shells. Same number of electron shells. Okay, same thing here, sodium and chlorine, they are from period 3. How many electron shells do they have? 1, 2, 3. Chlorine, 1, 2, 3. So 3 electron shells. So period 2, 2 electron shells. Period 3, 3 electron shells. How about the group? The group follows the number of valence electrons. So in group 1, lithium and sodium both have 1 electron in the outermost shell. So in this case here, lithium in group 1, so 1 valence electron. Sodium in group 1, 1 valence electrons. Fair? For group 7, so how many valence electrons do you expect? 7. So 7 electrons in the outer shell, 7 electrons once again in the outer shell for chlorine. So this is your so this is how you relate the group with the period. So same group equals same number of valence electrons. Okay, take note of this. So now, let's move on. Okay, now, what other things here do we have? You'll see that the bold zigzag in the periodic table here, there's a zigzag line which you always see. Okay, let me use a different color to mark it out. Use purple. You can see that there's a zigzag line over here. The elements that there's along the zigzag line is what we call your metalloids. So what are your metalloids? Do you know? These metalloids, they have properties of both metal and non-metal. So you know that on the left-hand side of the staircase line is what we call metals. Right-hand side is what we call the non-metals, which are also the ones in your blue, the ones in your yellow. The ones in your green is called your metalloids because they are in between your metals and non-metals. So they have both properties. Okay, sometimes they behave like a metal, sometimes behave like a non-metal. It's a little bit weird. Okay, it's a little bit weird. However, don't worry about it. Okay, they are not that weird. Okay, but however, we also don't need to worry too much as we won't be looking at it too much also. Now, let's try some quiz. Is hydrogen a metal or a non-metal? What is your answer? Answer is hydrogen is a non-metal. Okay, hydrogen is a non-metal. Next one. Silicon is a metal. True or false? Okay, is silicon a metal? Answer is false. Oh my goodness. The answer is false. Why? Because it is a metalloid. Sorry, metalloid. Okay. Now, next one. Iodine can conduct electricity. True or false? Okay, in actual fact, this is false. Why is it false? It's because iodine is a non-metal. Obviously, non-metal, can they conduct electricity? No. Okay, next one. Gold has a shiny appearance and is malleable. True or false? Okay, what do you think? Okay, now, this answer is true. It's because gold is a metal. These two are properties of a metal. Okay, we'll go into it later on, but just take note. Metals have a shiny appearance and it is malleable. Malleable means can be hammered into sheets. Okay, like aluminium sheets, aluminium foil. Okay, next one. Steel is a pure metal. True or false? Answer is false. Okay, why is it so? Now, if you say it's a pure metal, you should be able to find it in the periodic table. You should be able to find it in the periodic table. But look at your periodic table. Can you actually find the word steel? Okay, steel is not a pure element, so it's definitely not a pure metal. So that's why it is false also. Okay, now let's look at some of the trends. Okay, let's look at the properties of elements in period 3. So this is actually in period 3. All of them have how many valence? How many electron shells do they have? All of them have 3 electron shells. Oh yeah, I should say 3 filled electron shells. Oh yeah, or 3 electron shells with electrons. So, what do you notice about this, about their properties? Okay, for element, there's group 1 to group 0, so you have sodium, magnesium, all the way until argon. What's the property? Group 1 to group 3, you have metallic property. As we know, silicon is a metalloid, and then lastly, we have the rest being a non-metal. So you can see a decrease in metallic property. Okay, decrease in metallic property, or you can say it's an increase in non-metallic property. Okay, this is how it works. So from metal, it becomes a non-metal. That's why we call it decreasing metallic property and increasing non-metallic property. The other thing is also about the nature of the oxides. Okay, this is what we covered in acid and bases. For sodium and magnesium, they belong to the basic oxide. And as you shift along, it becomes amphoteric, then it becomes acidic. Okay, so from basic to acidic, that's the nature of the oxides. Okay, so if I draw like this, okay, I'll say that it's from basic oxides, okay, to become acidic oxides. So this is the property of the elements in period 3. It's the same for period 2 and period 4. Okay. Now the last part. Okay, so obviously we'll talk about our dear metalloid, which I've described just now. So you can see here, a metalloid is an element with properties intermediate. Okay, intermediate means in between those of metal and non-metals. Okay, so it's like a mix between metal and non-metal. So I've gone through quite a bit with regards to the periodic trends. Okay, talking about what are your metals, what are the non-metals. We talk about the properties, how you switch from metallic to non-metallic, oxide switch from basic to acidic. Okay, next up we're looking into each group. Okay, each group specifically. So that's all for this part 2.